All right, this is Mr. Smith here. This is section Algebra 6.5 and Algebra 2. We are graphing square root and cube root functions. Okay. We are graphing square root and cube root functions. Now, there are some nice aspects of this section. Go quickly. Number one, we're going to rely on the graphing calculator to assist us. That'll be helpful. Number two, we're only interested in square root and cube root functions. We're not going to look at all of the possible root function families that we could. That's going to make it nice. Number three, the key idea, the key emphasis from me to you is transformations. We've seen transformations before. They are exactly how they were before. There are four of them. The reflection, the stretch, the horizontal shift, and the vertical shift. Those are the exact same four that we've seen before, and we'll see them again. Okay, so we have our parent function. So in this case, here's our parent function, the square root of x. Looks like that. In this case, we have our cube root function that looks like this. Now, we are going to be introducing or re-talking about the idea of domain and range. However, the cube root function will have a domain and range of all real numbers. Always. So when we talk about domain and range here, on this function, the cube root function, the domain and range will be all real numbers, so that shouldn't be a big deal. Shouldn't be a big deal. Now, we will need to spend a little bit of energy talking about the domain and range of our square root functions. Okay. So here, they want us to graph y equals 2 radical x and compare that with y equals square root of x. So let us get the graph of y equals square root of x. 1, 2, 3, 4. So it should look something like that. Square root of x should look something like that. If you're like, well, Smith, where'd you get that from? Either I got it from my graphing calculator or I got it from right here. Okay. Right, so the domain of this piece, right, the domain of this piece is x is greater than or equal to 0. Right, so remember, you know, our understanding of domain, x is a real number such that x is greater than or equal to 0. And also range. Range talks about the y values. So in this case, the range would say y is a real number such that y is greater than or equal to 0. Okay. And we'll talk more about domain in a minute, range in a minute. Right now, I want to get this graph of y equals 2 times radical x in place. Okay, so how do I do that? I can make an xy table. Make an xy table. So square root of 0 is 0, times 2 is 0. Square root of 1 is 1, times 2 is 2. Square root of 4 times, so square root of 4 is 2, times 2 is 4. And so it gives us a graph that looks like this. And so the question becomes, well, what did that 2 in front of the square root do? Like that's my little wrap. Right, what did the 2 in front of the square root do, right? And the answer is that, well, it stretches this. It's a stretching factor. Well, that shouldn't be a surprise to us. We've seen transformations before. We've seen a number in front of the function piece. You know, so if this was y equals x squared, and then I took y equals 2x squared, well, what's that do? It does a stretch. What does this do? It does a stretch. And in this case, the stretching doesn't change the domain of the range, so we don't have to worry about that. And in fact, that's a minor part of this question. More importantly is to see this idea of a stretching. Also, we have the xy table, so we can use that. And we have our graphing calculators, so we can use that also as a graphing tool. Okay. Here, if we want to talk about y equals the cube root of x, if you want to know what the cube root function looks like, comes through these points. And roughly it does this. The domain and the range of every cube root function is all real numbers. So the domain is all real numbers, the range is all real numbers. And this is the orange is the graph, y equals the cube root of x. Y equals the cube root of x. And now they give us a negative 1/2. Well, what's the negative sign going to do? We've seen this before. What does the negative do? It's one of our 4 transformations. The negative gives us a reflection. So this gives us a reflection. What does the 1/2 do? Well, that's going to be a stretch factor. Okay. And so the transformation piece is the piece I expect you to see most importantly. If I wanted the graph, we could just go and either make an XY table, plug in 1, -1, and maybe throw in 8. So cube root of 1 is 1 times negative 1/2 is negative 1/2. Cube root of negative 1 is also negative 1 times negative 1/2 is positive 1/2. And cube root of 8 is 2 times negative 1/2 is negative 1. Okay. And so what we see is we get a graph that looks something like this. And the domain of that graph is also all real numbers, and the range is also all real numbers. Okay. So again, our transformations that we've seen in the past are the same. They affect these graphs the same way. So here are 2 practice problems. For our time being, I'm going to skip past them and get to something a little bit more complicated. So here it is. Okay. This is the type of problem that I'm going to expect you to be able to accomplish on your homework. I expect you to be able to see the transformations. So we start with our graph of y equals x squared. Sorry, y equals the square root of x, which looks roughly like that. And now we're going to transform it. How our transformations work. The +2 here at the very end. The +2 is going to be a vertical shift up 2 units. We've seen that before, right? This -1 underneath the radical, that's going to be a horizontal shift. And remember, horizontal shifts go the opposite direction you expect, so this will go to the right 1 unit. What's the 3 going to do? The 3 is going to be a stretch factor. Usually we just kind of pencil that in. We play that a little bit by hand. We fudge this one. This one's the least important out of all of them. Okay? So here, let's apply our transformations to our function. So here's my function. I got it. And now we are going to go vertical shift up 2 units, 1, 2. We're going to go horizontal shift 1 unit to the right. And now I'm supposed to stretch this. So to stretch it, maybe I'll draw another one to get the stretched graph. And so our final graph should look maybe something like that. Okay, so there are 3 transformations. First, I did a vertical shift up 2 units, a horizontal shift 1 unit to the right, and then a vertical stretch by a factor of 3. And that's the new graph. Now, of course, we have our graphing calculators to verify this. We have our graphing calculators to help us make sure we get the stretch piece okay. But now they ask us about the domain and the range. Domain meaning what x values am I allowed, range values meaning what range values do I get, what y values do I get. Okay. So we're going to talk about domain. We're going to talk about domain. The idea graphically is if we walk along the x-axis, I start out here at negative infinity, and I walk along the x-axis. When does the graph start? It starts right here. Right? As I walk along the x-axis, where does the graph start? It starts here. Where does the graph end? Well, as I keep walking, I'm going to have to keep walking, and it's never going to end. So the domain is from -1, sorry, not -1, +1 to infinity. Right? As I walk along the x-axis, keep walking, keep walking, keep walking. Here the graph starts. Where does it end? It doesn't. So the domain is from 1 to infinity. And we've seen this before. I've asked you questions about domains here, right? If I plug in a 0, I'm going to get negative underneath the square root, and that's not allowed. I don't want to get a negative under the square root. If I plug in -3, I get a negative under the square root. I don't want a negative under the square root. That's not in the domain. If I plug in 0.5, I get a negative under here, so that's not in the domain. But if I plug in 1, and any number bigger than 1, I get a positive number in the square root. That is in the domain. When we talk about range, range asks the question, what y values do I get out? So to answer a question about range, we start at negative infinity. Start at negative infinity. And we work our way up. And I ask the question, where does the graph start now? And here it starts at a y value of 2. So the range is going to start at a y value of 2. And where does it end? Well, as I keep going up and up and up and up and up and up and up, the graph is going to also keep going up and up and up and up. So the range values go from 2 to infinity. Range values go from 2 to infinity. So domain concerns itself with the x's, range concerns itself with the y's, and that is how we answer those questions. Another way to think about range is that whatever x value I plug in, it doesn't matter what x value I plug in, I could never get a y value smaller than 2. Okay, I could never, it doesn't matter what you think of, any number you can think of, if you plug it in there, the smallest y value you're going to get is 2, and the largest y value you're going to get is infinity. Okay, there will be no end. There is no largest value. Okay, that's the idea. Okay, here is a cube root function. Okay, so the last one was a square root. This is a cube root. Again, our transformation pieces stay exactly the same. What does this -2 do? It is a vertical shift down 2 units. What is this +3? It is a horizontal shift left 3 units. What's this negative sign do? It's a reflection. What's this 2 do? It is a stretching factor. Okay. So if we start, let's see. If we start with our original graph, that looks something like this. Sorry, I overdrew that. We start with our original graph that looks like that. That's the cube graph, right? That's the cube root graph. Excuse me, cube root graph. And so this is what I'm going to transform. And if I do these transformations, these 4 transformations, I'll get the new graph. One last question, domain and range. A cube root domain is all real numbers. The cube root range is all real numbers. Okay, so this is easy to talk about domain and range. If it's a cube root graph, the domain and range will be all real numbers. So this concludes section 6.5. Thanks for your attention. I hope the audio is at least manageable. Have a great day.